All right, it's officially 10:15. I don't see any people coming in at the moment, so we can get started. Welcome to the last day of NI Connect, and I guess the first presentation slot. My name is Greg Richardson. I have been working on developing LabVIEW for over 3 decades, so I've had my hands in a lot of pieces. But today I'm going to be talking about LabVIEW version independence. You've seen this slide probably a few times by now, talking about our 3 pillars of our software platform, strengthening, our core software, connecting workflows between products, and then building community. What I'm going to talk about today is pretty much squaring that strengthened software part. We're making our core LabVIEW usage easier and showing you procedures that work today. So within strengthening software, all these focus areas, this kind of splits between streamlined measurements, making your individual engineer development process better, and test development operations, because it also can impact your CI/CD. So it can help in that area too. So trying to give a little context to the overall picture of where this fits in. So let's start with the question. How many people have to support LabVIEW projects in different versions of LabVIEW at the same time? Yes, that's why you're all here today. So we know this can be an issue. Anytime you upgrade LabVIEW, there's the potential of new issues showing up, but there's also just the retesting to validate that your test systems still work. It's a lot of expense to that, so people don't want to do it all the time. Traditional approaches to this mainly fall between 2 camps. One is, no, I'm just going to have separate computers for each system, and they're both going to have exactly the software they need. Or you go the VM route, and so you make 1 VM for each system, and then again, each VM has exactly the pieces that it needs. But I'm spoiled. I'm a developer. I want to have the latest. I want to have the latest LabVIEW. I want to have the latest drivers, the latest dependencies. I want all the cool stuff. I want Nigel. I want long path support. I want the new debug window that's coming out in Q3. I want all the stuff they put on this big wordy slide. So how can I get all this but not force my company to upgrade their production systems? Well, version independence is a big help here, but there are some procedures around version independence that make it possible. So, first part is isolating your production builds from your developer machines. If your developer is using the latest LabVIEW and the latest drivers, then they shouldn't be the ones building your binaries that are put out onto your production floor. Not just because of that, though, also because you don't want your developers manually having to figure out, oh, do I have the right branch checked out? Do I have any unchecked in changes? No. To have good, version management, you need to have dedicated build systems that are producing your production builds and keep that off the developer's machine. You never know what they're going to do to their machine. You don't want them building anything that goes out onto the floor. So kind of step 1 is making sure you have that CI/CD process. You have dedicated machines that have the right versions of all the software for whatever system is being built. And those can be run, on every commit or however you schedule them. But they're independent of the developers. Part of that is if you're building PPLs, make sure you turn on allow future versions of LabVIEW to load this packed library. That will allow your developer to use the latest editor and still load those PPLs if that's part of your process. If you're just dealing with source, make sure your source separates compiled code. Does everyone use that setting? Show of hands. Okay, most of you. Yeah, so that's another key piece to this. Next part is the project save version. We introduced this in LabVIEW 2023 Q3, but in the project settings, there's just a little drop down there for the save version, and you can set it back as far back as 2017, and all your source will stay in that version. It can be loaded in that version even though you're editing it in a newer version. So I can use LabVIEW 2025. I helped out in moving the icon editor to open source. And I can say that even though the icon editor open source project supports back to LabVIEW 2021, I did all the work to initially create that repo in LabVIEW 2024. But the project has the save version set, so I could create all those files, put them up into GitHub, and then anyone can use it back in 2021. So I'm not just saying this in theory. I've done this. It works. It's great. And if you're not familiar with this feature, if you use a piece of functionality that's not supported in the save version that you're trying to target, you get this little exclamation point in the state panel. And here it's showing, the red 17, meaning this VI can't be saved to 2017. And then if you click on that or just show the error list, there's a new category of errors in the error window for compatibility issues. And here it shows that the build map node is not available until 19. So if you really need that functionality, you can go change your save version and move up to 19. But otherwise, it just lets you know when you are using something that won't work. And if there are questions along the way, I should have plenty of time, so we can go ahead and have questions. We have a microphone.
Does the save version differentiate between different patches, or just the like Q1, Q2, Q3?
In general, okay. If we go back to the before we changed to the quarterly versioning, you'll just see like 17, 18, 19. Because the .1 releases were compatible and didn't need anything. As you get into the other ones, even though like LabVIEW 2023 Q3 is backward compatible with LabVIEW 2023 Q1, sometimes we will show both if there were features that were introduced in between. So that's why 2022.3 is an option. But in general, it's the major version that matters. We had another question up here.
I primarily deal with FPGA in real time. How are you going to talk about implications for that?
Not specifically. I mean, they should work. It's just the source code being affected. It's not the compilation, so it doesn't really matter. So yeah, it can be used on RT and FPGA VIs as well.
But the last projects that had FPGA parts, the project save
Oh, excuse me.
it's not the
Sorry. If you have FPGA targets, the save version is disabled, I'm being told. Yeah, okay. I remember some problems, but I thought we'd worked it out. So yeah, RT okay, FPGA no.
Is that coming? Is that on the roadmap?
Talk to me. Tell me your use cases. Product owner for LabVIEW.
Yeah, Christina Rogers, product owner for LabVIEW. Feel free to chat with her afterwards.
If you have older hardware like SCXI, for example, that you can't have later than LabVIEW 2018 on, and you have your project built in, let's say, LabVIEW 2024, but everything is saved as a save version 2018, can you make a build and load it to that hardware, the old hardware? Real time? Or do you need to make the build in LabVIEW 2018?
Yeah. Building is separate. Your developers can use it, can edit in the latest version, but if you're making a build, LabVIEW 2025 can't make a build that claims to be 2018. Because when you're running in the latest editor, you're using the latest version of the compiler. And so in general, it's close enough that for development purposes, it's fine to run that way. But to do your build, and that's why I said it's important to isolate your CI/CD, you need to be going back. And that also means that if you do have RT, for a developer, if a developer is trying to use the latest editor on his desktop machine, he would also need to have the latest editor on his RT that he's deploying to in that session. But then when you're doing your official builds, those would be done in the older version. So you'd still be using the older version RT on your production set. All right. So project save version. And then this is where we'll get further into dependencies. So it may be fine in one of my systems to use the latest drivers because they still work with everything, all the hardware that's involved there. But there may be times when you're using hardware that's older and support for that has been dropped in the latest version of the driver. So it may be fine to use the latest version of LabVIEW, but you need to use an older version of drivers so the hardware is still supported. And this can be done, but what it means is you'll have to go one step further and isolate your dependencies for the two projects. So when you're loading system 1, it's fine for it to use all the latest stuff, but when you're loading system 2, you need it to use older versions. And go through a few slides here that describe how that can be done. So first, let's talk about traditional LabVIEW add-ons. They installed into the LabVIEW installation directory. So everything just kept piling their own stuff into vi.lib and examples, which makes it really hard to isolate your dependencies because they've all just thrown their files together, intermixed. So part of being able to have this better control is using what we refer to as LV add-ons or version independent add-ons. This is a mechanism we introduced in 2023 Q3, or maybe slightly off on that number. I'm getting version numbers confused. But introduced it relatively recently, where instead of installing into the LabVIEW directory, there's a defined place on Windows, C program files, NI, LV add-ons. And each LV add-on installs into its own subdirectory within this LV add-ons. And any supported LabVIEW version for that add-on that runs on that machine can use that add-on. So you don't have to install DAC separately for 2023 and 2024. You install it once and both versions use it. This also really helps enable the next workflow I'm going to talk about, because LV add-ons, again, is used by all LabVIEWs that are installed and run on that machine. But if you're trying to control your dependencies per project, then you need some extra isolation somehow. Well, the location of LV add-ons can be overridden. So instead of using the LV add-ons, that fixed location, I can make my own LV add-ons directory that's specific to my project. and I can copy exactly the add-on versions that my project is expecting into that location. And then all I have to do is create an INI file that sets this LV add-ons custom location to point to that new folder I created. Now, this is a LabVIEW setting, not a project setting. So you have to make sure when you're launching LabVIEW, you're using that INI file. And that's where I suggest making a little script, batch file is fine, that can launch LabVIEW with the command line argument to specify, here's the INI file to use. And since I'm now using an INI file that's specific to my project, I might as well tell LabVIEW at the same time when it's launching, go ahead and load my project. So if I want to switch between projects, I need to shut down LabVIEW and relaunch with the batch file for the other project. But as long as I do that, then each project can have its own set of dependencies. So if one can use the latest stack, that's great. If another one needs an older DAC, then it can get that. Yeah, we have a question over here.
Thank you. How is different from Dragon? The tool from JKI embedded. Is the Dragon not talking about add-ons, but the code dependencies?
It's all working kind of in related areas. Dragon helps you get your dependencies installed and available. But by default, Dragon is just doing whatever the VI package or NI package does to install. So it's still just installing into LV add-ons or into the LabVIEW directory by default. So this is kind of a step beyond that of saying, I need my dependencies to be project specific. Yes?
So if you have, like, say you have two different versions of some driver, but you want to use the same version of DACMX for both, do you have to install DACMX twice, or how do you have it appear in both places?
DACMX is one of the packages that has been converted to an LV add-on. So it installs into the LV add-on directory. If you are trying to completely isolate, you can just pick that up and copy it into both places.
So you have to do the copying yourself. You don't install it to a certain location.
Yeah, you can do the copy yourself. There's other workflows you could do that are more complicated, but the easiest thing is, just copy it over. Again, it's an LV add-on, so there's just one directory that everything is under, and you can copy that.
Will LabVIEW be aware of the new relative path, and will that show up as a change?
We don't reference things from add-ons as relative paths. When you're referencing something from an add-on, it uses our symbolic paths. So we have a symbolic path for vi.lib, inster.lib, user.lib. As long as you're putting things in those locations, it doesn't matter. Because the way LV add-ons work is, if we go back, well, I guess I don't show it here. Inside the add-on, you would have like a vi.lib directory. And the way LabVIEW treats it is all the add-ons act like they're overlays on top of the LabVIEW directory. So when we're resolving a symbolic path of vi.lib something, we look through all the add-ons to find that. So the paths don't change. It doesn't matter where your add-on is, the path is still that symbolic path. Michael?
So I'm a little confused. So you're saying that if a package installs into VI-lib and you've defined your add-ons, if you've remapped it, so is it remapped to add-ons? So if the package is targeted to VI-lib, and now it installs in there?
No, this isn't about changing what the install does. I'm explaining the runtime behavior after everything is there. The install is going to go wherever the install for that package has defined. So if you're using an older package that installs into the LabVIEW directory, it's still going to keep doing that.
So the installer has to know about this feature and put it in.
No, but I'm going to touch on that in just a little bit. So let's come back to that.
For this solution, is there a recommendation for 32 bits versus 64-bit Bitness?
Up to you.
So for 32 bits, we should use the add-ons inside the National Instrument Project folder for 32 bits. That's what
They 64-bit and 32-bit go to the same place. And there's a way, I'll talk about here in a little bit, there's a way for the add-on to declare whether it supports both or is one or the other.
One quick question.
You have your own question? Come on.
Yes. So we are saying no more VMs. With VMs, so some of us don't have the flexibility of working on only one project at a time. We might have to open another one just because a client called and I need to quickly look at something. With this, because I thought I'm all powerful now, in one VM I can do everything. This kind of breaks our normal workflow where if you have a project open, you just go to file and say open this other project. And I can have both of these open at the same time. I don't need to close what I'm working on now. If creature of habit, if I accidentally do that, chances of cross-contamination, accidentally saving stuff with other versions?
There shouldn't be cross-linking or accidental saves in the wrong version because the linkages are all those symbolic paths. So when you load it with the right dependencies, you'll go back to using those. And the project save version is per project. So however you load that project, it's going to honor that. Now, if you're trying to run it and there's issues because you needed the specific version of those dependencies, it's going to have a problem. So yes, right now it does take a little bit of discipline to make sure you're running with the right INI file to get the dependencies you want if you're using this approach.
So you'll pretty much have a bunch of shortcuts on your desktop for each batch file, and that's how you load each project.
Yeah. But I'll also touch on that, talk about the future of that later. So this is just another look. I've created two projects that both have their own add-ons locations. They have the custom INI file. They have the batch file that helps me launch it. So you just create that for however many projects you have. Then we're going to go back and talk about, those non-LV add-on dependencies. So those things that installed into the LabVIEW directory. First advice for those is contact the author and complain. We're trying to get people to move over to using LV add-ons because it does create a lot more flexibility for the end user. It also avoids having to reinstall everything if you do a LabVIEW upgrade. Apply pressure from your side, get people to move over. But if you're in that situation, you can also try doing this conversion yourself. In most cases, it works just fine. But what it involves is identifying which files that add-on installed into your LabVIEW directory, and then you pulling them out and wrapping them into an LV add-on. And all that takes is, again, identify the files, create some add-on name inside your LV add-ons directory, give it a version directory, and then inside that, you just put all those files that you got out of the LabVIEW directory. So if there were examples, you have an examples directory with those files. If they put things into vi.lib, you have a vi.lib with those files. The only thing you have to add is this LV add-on info.json. It's a very simple JSON file. There are only 4 possible fields. One of them is optional, and 2 of them, we don't actually look at the value. It has to be there, but currently LabVIEW doesn't use the value for anything. So the add-on name, straightforward, whatever you want to call it. Usually that would match whatever directory you used. That has to be there, but it's not used in the product currently. The API version, similarly, probably want to keep that in sync with whatever version you're using for the version directory. But it's not used in the product currently. The minimum supported version is very important. So this is the one that says, my code only works in this version of LabVIEW and beyond. So you can set that. If you're trying to use some DAC device that we dropped support for in 2018, then if you can find all the right pieces of DAC and pull it out and say, yeah, this is my DAC driver, and it supports LabVIEW version 18 and beyond. I guess one other thing you need to do is set all the files to be source only, or separate compiled code, because dependencies, add-ons that distributed this way expected to be mass compiled in the LabVIEW directory to update the code, but we want them to be not have code, so we need to separate the code, and then it'll get cached in each version of LabVIEW and be transparent to the user. And then the last field is this supported Bitness. It's optional. If you don't have it, it means you support both 32-bit and 64-bit. But if you do have native calls that are only supported on one, you can set that to say it's only used there. This is used by some add-ons like DACMX, where DACMX actually creates 3 add-ons. They create their high-level add-on, which is Bitness agnostic. And then they create specific add-ons for 32-bit and 64-bit. And all those have are the binary DLLs. So if you're on 32-bit, you get the 32-bit DLLs plus the agnostic code, which has all the call library nodes that reference those DLLs by path. By symbolic path, so when they're running with the 32-bit subcomponent, they get those DLLs. If they're running with the 64-bit subcomponent, they get those DLLs. I'll talk later about another approach to that that wasn't available when DAC started being version agnostic, but is now. So when you're doing all of this, and particularly if you're kind of wrapping older add-ons yourself into LV add-ons, it can be really helpful to validate that you're using the add-ons you think you're using. And there's a really simple approach to validating that. This VI, there's the path in vi.lib, has shipped for several versions, but is not in the palettes. You still want it, find it. It resolves our symbolic paths. And if you use it and resolve this libdir, libdir is our symbolic name for the equivalent of the LabVIEW directory. So it's the LabVIEW directory as opposed to being vi.lib within that. So this would exist in all add-ons because, again, all add-ons kind of act as virtual overlays onto that directory. So here you can see I ran this and it gave me this long list of LV add-ons that are all currently in use by LabVIEW. And if you see any paths that you don't expect there, you know, ooh, something in my configuration's not quite right. I'm using things I'm not supposed to. But that's how you can check. Then I talked a little bit, Dragon came up. The need to relaunch LabVIEW to use a different INI file. Yes, we recognize there's difficulty there or disconnects there. So what we want to get to in the future is rather than having to isolate all your add-ons, that you can the project can know which versions you want to use. And that would, likely be based on the information that may have already given Dragon as to which versions of dependencies you need. And then when we load the project, we can look at that and let that guide which version of add-ons we're using. Now, this assumes that your add-ons can be installed side by side. Again, that version directory within the add-on directory structure is very important. So if your add-on is bumping that version, you can install them all side by side, and then LabVIEW can decide, oh, I'm not going to choose the latest one. I'm actually going to go back to this older one because that's what this project requested. So if we get to that point, then this becomes easier. You don't have to worry about relaunching LabVIEW. You just load your project, and it can use the right versions. So that mostly covers the development workflow of I'm consuming add-ons. But there's also the workflow of actually I'm creating reuse libraries for my company that we share internally. So yeah, how does version independence, how can you take advantage of that for your own components? And the first answer to that is, again, LV add-ons. You know, build your reuse libraries into LV add-ons and version them so that at important version boundaries, they install into a new directory so you can have multiple versions installed, and that will enable some of these workflows in the future. So first step is, yeah, build all these as add-ons. Now, how do you develop your add-ons? You know, developing something that's going to go into vi.lib can get tricky because if your source code isn't in vi.lib, you may also have this version of your source in vi.lib, and things can get really confused. Which one are you loading? You can cross-link between them. Bad things can happen. So you don't want the published version of your add-on to be available when you're developing your add-on. You want the source that you're working with to be what's used by LabVIEW. You don't want to have to copy that somewhere and then make changes here and then copy it back. I mean, anyone who's done that has done the inevitable of, oh, I copied the wrong direction. I just lost all my work today. So we don't want that. When you're developing reuse libraries, one approach that, again, I've done this for our own internal usage, is to create your source code layout in the form of LV add-ons. So in my source control, I have a directory called add-ons. Inside that, there's directories for each one, and underneath those are version directories and then all the content. Then instead of lvaddons.custom location, there's a second tag called lvaddons.additional locations, which can actually take a list of paths. But I can put this internals add-ons directory into that additional locations, and now when I launch LabVIEW, it sees that part of my source code as an add-on just like any other add-on. So if I am, launching a project, I can reference those with the same symbolic paths that they would use if they were installed. I can edit them in place and immediately start testing LabVIEW with those changes, because that's where LabVIEW is loading those files from. So yeah, it makes it much easier to develop the add-ons and not have to have some complicated build process that's trying to fix paths that might have gotten messed up because of the way you were developing. Having copies of files you modify is a bad thing. Having copies of files that you don't modify, like the add-on isolation workflow I talked about, is less problematic. Yeah.
So when you load the project with this specific ini file, it will only load what's in there, and the other ones will not be loaded into LabVIEW's memory.
No, with additional locations, this is saying do the normal thing plus these.
Yeah, but if you, my question is going to, if I put, could I put DAC MX or Vision into a additional location, and then when I start up LabVIEW, it doesn't have to load everything? Because I'm not doing Vision, so I don't want to have the long startup of loading Vision and DAC MX when I'm not actually going to develop on that.
Yeah. If you only wanted some of your projects to have that, then yes, you could use additional locations only when working on those projects, and other projects would not have it and not have those available.
So you don't have to, like if you have DAC MX Vision and you name it, like it gets pretty long load times, just startup of LabVIEW. You can skip that if you don't need it in this project.
Yeah. I mean, the startup time impact shouldn't be too huge because, well, normally we do pallet loading in the background. If you've set the setting to say load all the pallets immediately on launch, then it has a bigger impact. But yes, whatever impact there is would be avoided if those were separated. Harsha?
A couple of questions. Switching gears a little bit, how does the operating system version interplay with everything you said?
The operating system version really doesn't matter. We don't do anything specific. So unless it matters to some component that you have, we don't care.
Second is a visual ask from our side. Just like how you save to the previous versions of LabVIEW for developers, when we are building executables, for example, or deployments, it'll be nice to be able to say build for this previous version of Windows. That would...
Okay, not for a previous version of LabVIEW, but a previous version of Windows?
Yes, that would significantly streamline, because I'm sure we are not the only customer. Our products live in the field for multiple decades. We still have tools that run on Windows XP. For that reason, we painfully maintain the LabVIEW code that's developed in LabVIEW 6.2 today. I'm not saying you have to go that far, but at least a thought that the ability to deploy to previous versions of operating systems would go a long way.
Yeah. Right now, when you're doing builds, we're not going back and using the old compiler. So when you're doing builds in the version you're running. And yeah, there are some restrictions on the runtime engine, which versions of the OS it supports. And so I hear your problem. I'll tell you, that would be a very difficult thing for us to do. Now, I'll also say in a lot of cases, those restrictions are about what we've tested, not necessarily that there's known incompatibilities. In some cases, if you can get the runtime engine onto the older OS, it would still work. But it's not officially supported, so you're on your own. Yeah.
So I deploy my reuse code into user-lib, and of course it gets picked up into the palettes then when you launch LabVIEW, so you can access it. If I was to relocate the reuse code to this internal add-ons folder this way, am I still going to get that behavior?
Yep. Still put it in the user.lib folder within the add-on, and it'll still get picked up.
Okay.
So any of our palettes that sync to a directory, so you just put something in there and it causes it to show up, that again is using that symbolic path. So it resolves that directory across all add-ons, and we'll all add the content across all of them.
So if I make this move, it's just going to automatically relink and I won't have to go through and say, oh, everything's now over here now.
Yep.
Okay, that's great.
Okay.
Is this approach apply for a specific version of LabVIEW and on, or goes as far as what version?
These configuration tokens that I'm talking about, again, there's so many versions running around in my head, believe were added in 2023 Q3. So yeah, from there on, all of this should be available.
This one, the additional location and the
custom location. So when we're talking about consuming reuse libraries, this is similar to what I talked about before with general add-ons, but you can, provide these to the rest of your company through packages that install into LabVIEW Add-ons. Or if you don't want to have to go through kind of that installation process, you can define your own custom route and use the additional add-on or additional locations key to point to those. This is kind of like, setting up the symbol server in Visual Studio. It's just a little bit more configuration they have to do. To get your internal add-ons, they'd have to modify their INI file and point it somewhere. That could be somewhere local that is populated from your artifact management system, or it could be a network drive. You could just have your add-ons out on the network somewhere and everyone could reference them from there. Kind of up to you. It was all built to, we definitely wanted to make sure VIPM and NIPM supported them, but it was built to be agnostic of either of those. So however the files show up, LabVIEW will use them. It doesn't have to use those specific package managers. And then I also want to talk a little bit more about the Bitness specific. So I talked about having the Bitness specific add-ons, 32 and 64. Again, DACMX does that. But in 2024, I believe it was, we also extended an existing concept of the targets directory. So for a long time, we've had targets directories, and that's where you could put RT specific files or FPGA specific files. And so there were defined directories underneath this that RT and FPGA targets would use. Well, now we've extended that to the desktop targets. So there's a Win32 directory, a Win64 directory, a Linux directory, a Win directory that's Bitness agnostic. And these are all options for you to put more files in. Again, like LabVIEW Add-ons, this specific directory inside the add-on is then treated as another libdir. And so anything you put in there virtually overlays the LabVIEW directory like all these others. So you could create a user.lib directory in there, and the 64-bit version gets used in 64-bit LabVIEW, and the 32-bit version gets used in 32-bit LabVIEW. So that allows you to have one add-on that supports multiple, or both Bitnesses or multiple platforms, however much you need. Clear as mud? This is a lot of information. And this is the tamer version. I'm going to give you a link at the end here to the LabVIEW Wiki page on LabVIEW Add-ons. And it contains a link to a presentation I gave at GDevCon last year about this that gets into it's more focused on the details. Here, I'm trying to present it more as a workflow. This Bitness thing, have people run into those situations? How have you solved them in your cases? Anyone want to share?
When installing the different DLLs for different Bitness, either install it on their right program files, x86 or the program files for 64-bit inside the BLib. And the other one is just in your code adding the what's it called? The case structure for identifying what Bitness are you are and load the right one. So those are the two cases.
I mean, specifically for DLLs, there's also wildcarding. You can put an asterisk in the name in the call library node configuration dialog, and it will use different names for 32-bit and 64-bit. So if you're not familiar with that, if you run into it, you can look that up in the documentation or ask Nigel about it. Okay, so yeah, that's the end of my content. If we have more questions, but yeah, there's really just 3 key pieces to this. Use the project save version. Understand your options for isolating dependencies and using those custom LV add-on locations. And you know, I tried to give you kind of one simple flow through it, but there's a lot of different ways these tools can be used. You don't have to follow it exactly, but this gives you a lot of options on how you can approach it. And again, there's that QR code for the LabVIEW Wiki. Yeah, got a question, Michael?
So I have 2 questions. One is for the add-ons folder. So I don't know if you're aware, does VIPM currently and NIPM handle these new locations as symbolic paths, or like can you target them?
The VIPM support for LV add-ons is minimal.
Oh, okay.
You can set LV add-ons as a custom install location, but I don't think there's any way to redirect that. And what I was really hoping would happen was that VIPM could build in the capability of kind of automatically taking old VI packages and installing them as LV add-ons, which really just means changing where it installs and having some scripting to go in and say, separate compile code on everything and generate that little LV add-on info file. Wouldn't always work, but it would be really helpful in cases where it did.
I also want to comment for those using the save feature, the save for previous feature. I've run into some issues with that. So I just want to warn people about it. All your code has to be separate compiled.
Yes.
And has to be in either a library or a project. It has to be, because, for example, if you have an add-on that's not in a library and it's in LabVIEW already installed, you'll have issues with that. Like the save for previous doesn't work properly. So.
Yeah. I mean, if you're referencing it in the context of a project, it still should.
So I've had issues where I've opened old code and the version wasn't selected correctly or separate compile wasn't enabled. And then I'd had to actually go through and make sure everything was set correctly. So just
no, for separate compile code,
be careful
definitely.
about that.
In general, you know, it also takes a little bit of discipline to always edit your VIs within the context of the project. I fairly frequently will just open a VI and make some change and save it. And then later I realize, ooh, I just saved that in the wrong version. But the good news is it's really easy to recover from, because you just load your project, reload the VI, and the VI actually gets a doc mod that says, hey, I was saved in the wrong version. So you just have to reload it within the project context and save it from there, and it'll go back to the version you want.
There's issues where it's just dependencies.
Yeah.
So before all this changes here, the original recommendation was to install stuff into user.lib, and somehow that recommendation changed to kind of putting stuff into VILib, I guess. But I'm wondering what the recommendation is now. Is there any reason to use user.lib now when it's in one of these directories?
The main implication of user.lib versus vi.lib is the impact on the palettes. Because user.lib goes in one spot in the palette, and things in vi.lib, you have to use a different way to make sure they show up in the palette. But no, you can keep using user.lib. You can
Was
make
there a reason to keep using it, just the palettes, or?
Really, the main difference is just where it shows up in the palettes. So if you put it in user.lib, there's already a palette that's going to auto-populate from that. There is not an auto-population for the top level of vi.lib. So you have to be a little bit more careful about where you put it in vi.lib to make sure it is going to auto-populate. And user.lib doesn't have that issue.
Thanks, Greg. How well does this play with PPLs? Because we've moved our whole framework to PPLs, and they work well now that I've sacrificed my third child. But we dare not move past and things like that. Like if I move a PPL, it'll just break the build randomly and stuff like that. So I'm nervous to move my PPLs again because I have to manually relink hundreds, just so much crap. It's unbelievable. So, but have you tried this with PPLs?
Yeah. PPLs work just as well in this scenario as they do in a normal scenario. If you were hitting problems with PPLs, those may still happen. But no, PPLs are fine. Again, as long as the PPL is set to be loadable in future versions of LabVIEW, then you can build it in your official version through your CI, and then developers can still use that even if they're using a later version.
Okay, so if I set up all those additional dependency things in the ini file and opened a project, I wouldn't have to relink any of my existing VIs, hopefully?
No. They'd use the symbolic path to find the PPL. They'd be able to load it because it's set to be able to load in future versions. So should just work.
Are there any considerations when running VI Analyzer against a project set up this way?
Shouldn't be. You can run VI Analyzer in your official version or in the latest version, and it should give you the same results. Which also brings up another interesting point on this. We have made a lot of improvements to VI diff, and added the ability to generate a single file HTML diff report that has images of each difference plus the list of what all changed, which we've had great success using that directly in pull requests or reference from pull requests to allow people to see what changed without having to launch LabVIEW. Even if you're not enabling your developers to use the latest LabVIEW, you're pinned to some version, you can create an automated build that uses the latest LabVIEW to do your diffs and generate those reports. So you can get the advantage of all that new diff reporting without having to impact your daily workflow at all. You just can make a pipeline that as soon as you create a pull request, it's going to run and do diffs of all your VIs and post comments back to the pull request with either the content or the links. So you don't have to do that diff in the same version of LabVIEW. You're not saving anything, so there's no issue of possibly corrupting anything. You just get to use that newer diff. All great reasons to be on contract so you can have access to the latest builds, even if you're not upgrading immediately.
So you might have mentioned this already, but if you did, I missed it. So what version of LabVIEW allows you to save us the whole project? 2025?
20. 24 Q3? 24 Q3 is the consensus. I'm sure it's right.
Thank you.
Those are two smart people back there. All right, well, that's all I have. So thanks for coming. Hope this helps. And if you have any other questions, if you see me around the rest of the day, feel free to snag me and ask.